Well, dear students, in this video I am going to discuss a very important topic of oscillations called force oscillation and resonance. I have noticed in my student teaching life that people struggle with this topic and do not understand properly what is the meaning of resonance and what is the meaning of force oscillation. They can understand, but meaning of resonance, the word is resonance. You have learned resonance somewhere also other than physics. In chemistry, resonance occur in structure of chemical compounds. I am not talking about that. We know that every free oscillation died out because of damping. For example, simple pendulum or mass dash to swing, when made to oscillate due to damping, the vibration stops sooner or later. Then how to maintain the vibration? The natural vibration of oscillating body like pendulum or mass attached to spring. Natural vibrations of oscillating body like pendulum or mass attached to spring die out due to damping. So the vibrations or oscillations of body may be maintained with constant amplitude by applying an external periodic force or driven source, driven जो drive करता है force. While I'm talking about this periodic force, example like suppose you are sitting in a swing, जिसे हिंदी में झूला कहते हैं. You are sitting and you want to maintain constant amplitude. Then either you press the ground with your leg, foot, or you ask someone to push your continuously at regular interval, then amplitude of vibration is maintained. So that force applied by your friend who is pushing the swing after some time regularly, that is called periodic force. So like that, there are many examples here. Now, so when we apply, so when a body oscillates under the action of, so the oscillations of a body under the action of external periodic force the oscillations are called periodic force are called forced oscillations or vibrations or forced vibration. Let the external periodic force is given by Ft is equal to F0 cos omega d t. Omega d means the frequency of driver source or periodic force. Now, this is equation 1. This is the applied periodic force. Now, a body is oscillating under damping force and has acceleration A at any time. If at any time the acceleration of motion be at and mass of body Bm, then from Newton law we can write m a t. T means acceleration will keep on changing with time here, is equal to, it is equal to restoring force K kxt minus bvt. It is the damping force, it is the restoring force, plus ft means f0 cos omega d into t. Or you can write it here as md2xt upon dt square plus b into dxt upon dt plus k xt is equal to f0 cos omega dt. Equation 2. So this is the equation of motion of oscillating body of mass m under the action of applied periodic force. This is the equation of motion of an oscillator under the action of applied periodic force. F0 is the amplitude of that force. Periodic force also vary in magnitude and direction, and F0 is the amplitude of force. Omega d is the frequency of applied periodic force. Please Take it very serious, dear students. I am telling you. I had been student also, and still I am student, because every day I learn something new. So here I have written xt means position of oscillator at time t. This indicate this thing. So initially, when we apply periodic force, initially oscillator oscillates with its natural frequency. Natural frequency. I have seen people struggling with the meaning of natural frequency. क्या मीनिंग है नेचुरल फ्रीक्वेंसी का? Oscillator oscillate with this by pendulum time period 2 pi under root L upon G. At any place G fixed, L can be varied, and hence frequency n equal to 1 upon 2 pi under root G by L. So L will give the frequency of simple pendulum. And if we change L, the frequency changes. So that frequency which depends or which is there because of geometrical shape and size of the oscillating body is called natural frequency. Longer the length of swing, slower the frequency. You might have seen the swings of different length. Shorter length swing oscillate frequently faster than longer length. So that is the meaning of natural frequency. This is very important to understand what is the meaning of natural frequency. बहुत जरूरी है समझना है यहाँ. The frequency of body which comes out due to the structure or formation or shape or size of the body. But due to this damping and due to the applied force, due to damping and applied periodic force, natural vibration, natural vibrations of oscillator die out and the oscillator oscillates with the frequency of applied periodic force. ये जानना बहुत ज़रूरी है. It is very essential to know कि when we apply periodic force and frequency of periodic force may be different from the natural body. We will discuss here later on. तो जो नेचुरल oscillation of the body, जैसे आपका स्विंग है, झोला है, पेंडुलम है, वो इधर आ रहा हो उधर, तो damping will be produced by the applied force also. Damping is there already, but damping also produced by applied periodic force. So those natural vibration is which depend on the shape and size. They will be finished. They will be stopped. Or oscillator stops oscillating with stationary frequency and start oscillating with the applied periodic force. And here the displacement of the oscillating body, the displacement of oscillator under driven frequency is given by xt equal to a cos omega dt, where a is the amplitude, omega t plus phi also, sorry, plus phi. Phi is the initial phase. Here a is the amplitude of oscillation under the action of applied periodic force. And the analysis of that equation and the analysis of equation of motion under periodic force gives the amplitude as A equal to F0 upon m square bracket omega square minus omega d square whole square plus omega d square b square to the power half. So the amplitude of oscillator is governed by natural frequency as well as driven frequency. The video will be little longer, please watch it carefully. So this amplitude of oscillation of oscillator under the action of driving force will depend on frequency of natural frequency of the oscillator and driven frequency as well as on mass and damping is also there. Now we will consider here two cases. Number one, case A, when driven frequency when damping is small. And omega d is far away from omega. मतलब जो ड्राइवन फ्रीक्वेंसी है इट इज हैज ग्रेट डिफरेंस है भाई फ्रॉम द नेचुरल फ्रीक्वेंसी. In that case this term negligible. In this case A will be how much? F0 upon. ये negligible होगा तो it will be m bracket omega square minus omega d square. Power half cancel because of this square. Here this amplitude A, I am doing that is F upon m square omega minus omega square minus omega d square whole square plus omega d square b square to the power हाफ, ये है ये। तो b जब छोटा होगा, डैम्पिंग इज नाइली स्मॉल, तो दिस टर्म विल बी एप्लीकेबल। In that case, further you can write f on m omega square common 1 minus omega d square upon omega square. So when omega, so this is the amplitude, but it will be changing, amplitude will changing if we change omega d. If the frequency of applied force is changed, frequency of applied force is changed, and it becomes closer to when omega d upon omega is equal to 1. So amplitude should be infinity, but it is never infinity because damping is not zero. At this condition, in this condition, A should be A equal to infinity, but this condition is never obtained. Why? Because damping is not zero. It has some significant value. But amplitude will become large when omega d equal to omega. And here is a graph showing the variation of displacement with omega d upon omega. So with different amplitudes, here it is 1.5, 0.5, 1.5 and 2 like this, xt. So at low value of damping, the graph may be like this. At high it may be like this, or maybe like this, and simply like this. A, B, C, D. Here A less than B less than C less than D. And if damping becomes zero, then amplitude may go infinity, but that is not there. So amplitude will be maximum when omega d close to omega. This equation shows this. Now case 2. Case 2, the B equation क्या है? If damping constant B had some reasonable value, and omega d close to omega. Omega d I am telling again, driven frequency, omega natural frequency. Then A will be given by f0 upon m into omega d into b. A will be, sorry, m नहीं होगा क्योंकि छूट जाएगा ना. This was A was there, f0 upon m square into omega minus square minus omega d square plus वो अलग था whole square और omega d square और बी स्क्वायर टू द पावर हाफ, तो ये छोटा हो जाएगा तो ये बच गया ओमेगा बी इंटू डी। सो व्हेन ओमेगा क्लोज टू ओमेगा डी, amplitude is large but never infinity. Why? Because of this factor. Damping is always there. So amplitude may be large but not infinity. Amplitude will be large but not infinity because and therefore when omega d is close to omega and B has a significant value, then amplitude A will be sufficiently large but not infinity. Now I, oh sorry, 26 minutes, oh, ज़्यादा लंबा हो गया, 5 मिनट ले जाएगा कोई तो। This phenomena of forced vibrations in which frequency of applied periodic force omega d is close to natural frequency omega, then this phenomena of force of vibration in which frequency of applied periodic force omega d close to natural frequency omega and amplitude of oscillation becomes large is called resonance. In our life, resonance has a very important application. I will take in next video because it will become very long. So resonance is the phenomena of force oscillation in which we increase the amplitude of oscillation by bringing the driven frequency close to the natural frequency. Please watch the video carefully, make the note, read the book also, NCERT book and other books also. But this is very important, dear friends.